go. All right, inverse property. The first row is the straightforward row. The exponent comes in front. Shh. Log base 2 of 2 is 1. You get x. All right. Oh, yeah, common log is base 10. But these don't match. Okay? The exponent comes in front. Log base 10 of 100 is 2. So you get 2x. Let's say you want to do it the inverse way, matching bases. Log base 3 of 3 squared x, right, because 9 is 3 squared. What if you're really getting to the inverse way? Those two things do cancel each other out, but the exponent comes in front. That first row, you've got other properties and skills to simplify it. The next row, not so much. You've really got to know the property to do the next row. The reason we're putting inverses together, we're about to solve equations. How do you solve equations? You use inverse operations. So we have to practice this first. Question.
How come it's 2x and not x squared?
Because the exponents right here, they're multiplied together. Okay? So I'm going to rewrite this m for magic. And m equals log base 5 of 1. So far, all I did is I separated these two things just so that it was easier to look at. And all I did is I took my exponent and I called it m for magic. And I'm going to rewrite this thing to the right side of the dotted line, just because I'm kind of curious. 5 to the m equals 1. Am I trying to figure out what 5 to the m is? It's 1.
Because 5, log 5 and log 5 are...
But this is why they cancel out. It feels like magic, but it really does work.
Isn't it just because log 5 cancels out 5? Oh. Is that why?
Yeah, you're going to remember to cross these things out, but I want you to have a deeper understanding of why it crosses out.
Why does it cross out?
Okay, so I'm going to highlight my substitution. Okay, I'm going to take this exponent, log base 5 of 1, and I'm going to rewrite it here. Do you see how I put an m and then I just rewrote it? I made my own substitution to help me. And then I took this expression, this equals, and I put it in exponent form. Look what happened. 5 to the m equals 1. So 5 to the m equals 1.
But what happens to the log of 5?
I'm trying to evaluate to the left of this dotted line. The right side of the dotted line is just my thought process.
Oh, because in a normal log...
Okay, so let's do it again. This is 10 to the m, where m equals log base 10 of 2. Now I had to write in the base of that exponent there because it was missing. It was the common log. These two things composed together, right? That's what substitution is composition, actually gives me the original statement. Now I'm going to rewrite 10 to the m equals 2. I'm actually trying to figure out what 10 to the m is. It's 2. The inverse property says they cancel each other out. Do you have to show me the process every time? No. But I do need you to understand I'm not making this up. It is an actual property that I can prove to you it works. Yes?
So when is the scenario where, like...
It doesn't quite work?
Where memorization would be useful? Like where you had to...
Honestly, every time I would just do this.
Yeah, okay.
Oh, no, I'm not going to show it. I'm going to know that, like, I could, but I'm just going to cross these things out knowing that this is the inverse property. That, right? This is what your work is going to look like. That's it. But I do want you to understand there is some reasoning behind it. I'm not just going to cross these things out and be like, oh, I don't know why this works. I'm just going to put it here. Yes. So, all right, I'll do it one more time here. I am going to create a substitution. So 2 to the m, where m represents the exponent. Right, I'm creating the m so that I can separate this log because it's kind of hard to, I don't know how to evaluate a log in that spot. So I'm gonna rewrite it over here, and I'm gonna see if I can figure out what to do with this. And in the rewriting step, right, keep in mind I'm trying to figure out what 2 to the m is. The right side is like my scratch work. Oh, I end up with this statement that tells me that 2 to the m is 9. You're like, somehow it matches. Well, it's going to match every time the way the inverse property works. Okay, we have to get to the ones that don't quite work the first time. 9 and 3. 9 and 3 are not the same. Means you have to do a little bit of work with your properties first. 3 squared. But you cannot cross these things out because the 2 is in the way. So you're going to have to move the 2 before you can cross these things out. So you get 3 log base 3 of x squared. Yes, I'm going to be like, okay, I get it. They cancel out. X squared. Once you understand these things cancel each other out, you're not showing me the magic number. You're just going to do it. No, I just like it. But it feels like, yeah.
So if it's x times log, then it'll be, so if it's x times log, whatever number, it'll be,
The x will become the exponent.
and then if it's whatever number times log with x, it'll be
Okay. Let's look at number 17. Oh, I have 2 exponents. I have a log exponent and a number exponent. And so I'm going to separate the 2 different types of exponents with my exponent property. Because the inverse, it only works for the log part. It does nothing for the plus 2 on the end. Okay. Yeah, what's 5 squared? That 2 is an exponent. I'm going to highlight the exponent, and I'm going to let you think about the properties I just used.
Oh, you distributed.
I did my exponent property because the log and the 2 are separate exponents added. But the inverse part only applies to the log exponent. It does not change the 2 exponent. Yes.
But why would you multiply that?
Okay. When you add exponents and you separate them, you are multiplying. So this plus, when I separate, turns to multiply. Right? Properties. Okay, give the last 2 rows a try. Think really carefully about how you're using your properties. No. I'm not going to have you multiply numbers up. You're going to have to use your properties to make this inverse one work.
Okay. So if I say negative, you would do negative 6.
So it's actually 72?
No, it's 72 to the negative 1 power, right? So, no, because negative is not distributed, right?
So it is X over 72?
Yes.
So when you separate it like that, this negative goes where?
So the power on the 72.
Why is that? Oh, because it
Because of
so it's 72 to the negative 1.
yes.
I make that 4 to the 1/2. You can't change the base of the log. You're gonna have to change the other one. 4. Okay, square root of 4 is 2. So 4 to the 1/2.
Not serious.
Yes. Just next to the first.
Wait, did you
Wait,
get?
what did you do with negative?
But this is 70, no, this is a 72 to the negative 1 power.
Wait, how did you get?
Then you get it.
Oh, you right?
So then this is, so it ends up being negative divided by 72.
Yeah, but also X. Well, actually, no, because it's not 1 over 72. It's X over 72.
That's why.
Why is X sometimes X? Because if we go with yes, 1 over 72 times
There's no grouping symbols here. No, this is a group. What do you do with the base? Not.
Oh, no, 2x.
This.
How do you take care of the negative?
You make it an exponent. Okay, watch this one. 3 squared.
You're acting. I swear in hell's God. Scott.
Okay.
Okay, so Britt, you can't have things separated like in
Okay.
Should I separate before I do that?
right there. Right there.
Or the negative?
Are you okay with this one then?
So my first step. Oh my gosh.
I can't just
This actually, I got it to the first.
Why?
Because it's hard. Because if you make it so square,
separate the different types, right? Separate the two exponents so that you can actually do the properties. All right, guys, here we go. Okay. I have two exponents, so I'm going to separate them. Right? Exponent property. The properties are not going to be tested individually. They're just going to happen to show up in problems, and you're going to have to use them. All right. Now, this is just x to the first. This is not quite an inverse property yet because I got this negative hanging around. So I'm going to move my negative to the exponent slot, okay, of just this, right? If I cover this, move the negative to the power slot. Log base x, 72 to the negative 1. And now it's an inverse property. Hold on, I'm going to erase this because it's like the wrong size. Which is right. Okay, so this ends up being 1 over 72 because a negative 1 power is a reciprocal. And this was just x to the first. Okay, number 19.
Wait, how come you don't distribute it to the 1 as well again?
I did.
It's not X over 72?
It is x over 72.
Wouldn't that be x to the negative 3?
No, look at your grouping symbols. You don't have grouping symbols here.
Oh,
It's only on the log. Okay. Watch my first step. Okay. Separate your exponents. You can't do this inverse property with multiple exponents. It's just one of them. Now, the second piece, right, yes, inverse property, ready, got it. First part, not quite ready. I got a 9 and a 3. You cannot change the 3. You're going to have to change the 9. 3 squared. Look at how nice and neat the size of these letters and subscripts are. Okay, 3 log 3x squared. Inverse property. So I get x squared times x, or x cubed. Well, this is by far the harder inverse property to use. Okay? This is the harder one where the log is in the exponent. Let's do our last row, which is the easier of the properties. I'm going to do this one where I take my x plus 1 in front. Oh, that's just a 2. 2x plus 2. Log base 3 of 9 is 2, and I distribute.
What?
Okay, 2.
Wait, so you can get rid of the bracket bars basically?
Well, exponents, good question. I'm not just getting rid of them. I'm taking the exponent here, and I'm moving it to the coefficient, which is my power property. Okay, right? I'll do it again. A different way. Let's say that I like the inverse property way. Well, I make a matching basis. I cannot change the base of the log, so I change the other one. Well, 2 is the square root of 4, just 4 to the 1/2. And I'm like, oh, inverses. Because the bases are matching. When the bases are matching, they cancel each other out.
Because it's like to the 1 power.
Yeah, the x is still there. So the 2 turned into 4 to the 1/2. So 1/2 and x are what's left.
Wait, why isn't it just x to the 1?
Look at where the exponent is. Okay? And notice that I don't have a coefficient here. I'm not moving anything like squared. Yes. The other way? Okay, so which I would do this. What's log base 4 of 2? 1/2. Yeah. So that's why this one's easier, because you don't have to do it like this. You can just move that exponent down and evaluate. Okay, so let's do the last one. See your exponent, the whole thing can come down. Log base 4 of 16 is 2, so I distribute. Oh, there you go. Got you.
Dude, if this is what's on our test, we're fine.
That's the power property.
You're about to get your hair back.
Because I distributed,
So it's like,
I distributed. Yeah? Alright guys, we have 9 minutes, so we're not going to finish solving today. We're going to have to finish it tomorrow, but we are going to go ahead and start it today. Okay? Now comes your notes. Yep.
was so excited to play.
Quiet. Thank you. Shh, guys. Thank you. Okay, we've already done 2 of the 4 types of solving. Okay, so we are almost, right, 50% done with the solving. You've got to practice a variety of questions. So when you're looking at your homework, you're picking different formats to look at. Make sure you pick ones with exponentials. You pick ones with logs. Now, I highlighted the x because we're solving for x. The y is just a placeholder. And so how do I solve for x in the number 3 statement? Yeah, b to the y equals x. Notice that rewriting is what allowed me to get x out and to isolate it. Right? Solving is isolating. Okay, so we're going to write in the 2 other types of questions. And I've got till 25, so we've got 7 more minutes. Okay? I'm going to write in this type, log base b of x equals log base b of y. And I'm going to highlight the x because the x is what I'm trying to solve for. And if you think you know what goes on the other side of the implication, I see 1. I'll wait for a few more people to think they have it. 2, 3. Wait for
Oh, I thought you pointed out it.
No, I was just counting. Okay, yes, we'll put it up. Yeah, guys, look. Common parts, corresponding parts. Just like number 1. It's like, why didn't we do number 2 already? Because you could. Okay? Corresponding parts. Number 4.
Are these like rules?
This is types of problems. So notice in the first line, I've got 2 exponentials, 2 logs, 1 log, 1 exponential. And so when we try to solve these equations, you have to pick strategies to help you do it. And so you kind of have to think of, well, what type am I looking at and what could work to solve this? Yeah, log base y equals x.
Oh, I mean, wait.
Yeah, this is right. Oh,
Wait, no, I'm sorry. It's log base. Isn't it log base?
yeah, log base b of y. Yes.
Wait, how do you? Sorry.
Rewrite it to a log statement.
How do you even get it into a log statement? Oh, because it's already in the log.
We're going to go over it. The inverse property is actually going to help us today.
Oh, because it's I'm sorry. I didn't mean to.
We're going to do 2 questions. 4 times e to the x plus 2 equals 10. Right, we're solving for x. How many exponentials do you have? 1. Category 4. There's only 1 exponential. How am I going to solve this?
Move the 4 up into the power.
You could move the... No, you can't. That's not a log. It's not a log.
I hate it when people do that.
5 halves. Guys, you are trying to isolate your x. Notice here, this is like the very last step before you get x equals. That's what you're aiming to make it look like. Isolate the exponential and then rewrite it.
Can you square root that now?
No, because you have an x plus 2, not just a 2. And I don't know how to do a x plus 2 root. Okay, this is going to be our last question today because I have to introduce to you a vocab word. This is called...
Oh wait, is that as much as you can say?
No, we're getting there, but I want to show you something that goes with this. An inverse operation is called... It's going to look like rewriting it. That's what it's going to look like. But it actually has a name. I don't know if I made this name up or not, but I think I've seen it in a book. Yeah, logging. It's like dividing. Divide, dividing. Log, logging.
You should like publish that word.
I know, I think I have seen this in the book. It just sounds weird. You're going to take the log of both sides of the equation. And here's what it looks like. Okay, literally, you divide both sides by something. You log both sides by base E. Why E? Because that's the base I see in the problem. And then you just copy down the left side of the equation and the right side of the equation. Look at your inverse property on the left side. That's why we do inverse property, guys.
Why are you said able to do that?
Why can you divide both sides by 4? Right, property of equality. As long as you're doing the same operation on both sides, it remains equivalent. Right? We're extending our properties of equality here. All right, guys, what do you get on the left side?
X plus 2.
Yeah, x plus 2.
No, because not everything is e to the x.
Okay, do you almost have x equals? Almost. Minus 2. Minus 2. That's it. That's it. Did you get x by itself? Yes. Is this log statement some number? Yeah, I just don't know what it is. Because it's e and it's a 5 halves.
Oh wait, so it's log. So
it.
it's log e to cancel out the e.
Yes, to cancel out this.
Just like oh, it's log.
Look, there's your inverse property. Okay, clean up.